using a graph to determine where a function is increasing, decreasing, or constant. As part of exploring how functions change, we can identify intervals over which the function is changing in specific ways. We say that a function is increasing on an interval if the function values increase as the input values increase within that interval. Similarly, a function who is decreasing on an interval if the function values decrease as the input values increase over that interval. Now, the average rate of change of an increasing function is positive, and the average rate of change of a decreasing function is negative. Now, figure 3 shows examples of increasing and decreasing intervals on a function. So going from left to right, you can see here that from here we are increasing when we get to this point here. So what that's saying is that the output of B is greater than the output of A, where B is greater than A. Now over here, we can see that it's now going to start decreasing in that interval. And that means that the output for B is less than the output for A, where B is greater than A. And then over here, we're going to start increasing again. So again, that means that the output of B is greater than the output for A, where B is greater than A. So what it's saying here is that the function, this is what the function is, it's increasing. So from negative infinity until it gets to negative 2, that means that the function is increasing. And then from negative 2 all the way to positive 2, you can see that it is decreasing. And then from positive 2 to positive infinity, it is increasing. Now, while some functions are increasing or decreasing over their entire domain, many others are not. A value of the input where a function changes from increasing to decreasing as we go from left to right, that is, as the input variable increases, is called a local maximum. If a function has more than one, we say it has a local maxima. Similarly, a value of the input where a function changes from decreasing to increasing as the input variable increases is called a local minimum, and the plural form is local minima. Now together, local maxima and minima are called local extrema, or local extreme values of the function. The singular form is extremum. Often the term local is replaced by the term relative. In this text, we'll use the term local. Now, clearly a function is neither increasing nor decreasing on an interval where it is constant. A function is also neither increasing nor decreasing at extrema. Note that we have to speak of local extrema because any given local extremum as defined here is not necessarily the highest maximum or lowest minimum in the function's entire domain. Now, for the function whose graph was shown in figure 4, we have a local maximum at 16, and it's occurring at x is equal to negative 2. So what that means here is that if we take a look at the value for x, here's the value of x at negative 2. Now the value for y is 16. So that means that the local maximum, as high as it goes up to 16, and it occurs at the value of when x is negative 2. Now, similarly, we can see that there's a local minimum at negative 16, and it occurs at positive 2. So here at positive 2, or when x is equal to 2, we can see that now there's a minimum, a local minimum at negative 16. Now, to locate the local maximum and minima from a graph, we need to observe the graph to determine where the graph attains its highest and lowest points, respectively, with an open interval. Like the summit of a roller coaster, the graph of a function is higher at a local maximum than at nearby points on both sides. The graph will be lower at a local minimum than at neighboring points. So figure 5 illustrates these ideas from a local maximum. So here we have an increasing function. So as it increases, it stops here, which then becomes a local maximum, and then it decreases back. Now these observations lead us to a formal definition of local extrema.